Okay, so let's look at number 23. When we know the discrete probability distribution has certain properties, sometimes there are shortcut formulas for calculating probabilities, means, variances, and standard deviations. In this case, the discrete probability distribution is binomial. For the binomial, the shortcut formula for the mean is mu equals n times p, and the variance is sigma squared equals n times p times q, where q is equal to 1 minus p. In the examples represented in the previous questions, n is the number of flips, p is the probability of getting tails on a single flip, and q is the probability of not getting tails on a single flip. We want to use our shortcut formulas to calculate the mean, the variance, the standard deviation for the questions in 19. D, we want to answer whether the shortcut formula used in parts A, B, and C give you the same result as in question 22. And then in E, F, and G, we want to do the mean, the variance, and the standard deviation for question 20. All right, so let's start by doing the mean of question 19. All right, now let's notice that the mean, we need n and we need p to do this shortcut formula. N is the number of flips and p is the probability of getting a tail. All right, so if we look back at number 19, whoops, I think, let's see if it's gonna let me. Yeah, it will. All right, so number 19, we are flipping a coin 3 times. So n is 3 times, and we are looking at the number of tails. So every time we flip a coin, we have a 0.5 probability of getting a tail, half basically. So um, 3 coins, 0.5 probability. So let's go back here to 23. And I'm going to try to put this draw feature on. We'll see if this thing works. All right, so our mean, mu, is n times p. So we were flipping 3 times, that's our n. And each time we flipped, we had a probability of a half, or 0.5, of getting a tail. So 3 times 0.5, our mean is 1.5. All right, now let's get our variance. Now, according to this, our variance is n times p times q. And q is just the probability of 1 minus p. So 1 minus 0.5 is still 0.5. All right, so I'm going to do that out here to the left just because I write kind of big with I'm writing with my mouse, and unfortunately, it's like a first grader's writing. All right, so n was 3, p was 0.5, and then 1 minus p was also 0.5. And I will put that into the calculator. It's really going to be 1.5 times 0.5. And that ends up being 0.75. So there's our variance. Now our standard deviation, even though it doesn't give our standard deviation up here in the shortcut formula, is always the square root of the variance. So let's just do the square root of 0.75, and that'll give us the standard deviation. And that ends up being 0.866. So our standard deviation is 0.866. All right, so question D, does the shortcut formulas used in part A, B, and C give you the same result as question 22? Now, the answer should be yes. The shortcut formulas will always give you the same result as the regular formula does. So you should be able to look back at your 22, and these should match the questions, the answers you got for A, B, and C on 22. Now, if you did not get those answers on A, B, and C in 22, you might want to look back at your process there. All right, so let's look at E, F, and G. We're going to do the same thing, but for question 20. So we need to figure out what n is and what p is in question number 20, and then we can plug them into these shortcut formulas. All right, so I'm going to scroll back. I think I have to leave the drawing, so let's take that off of there. We'll go back to number 20. All right, so in 20, I am flipping a coin 10 times. My probability of getting a tail is still 1/2. All right, the only thing that changed here was the n, which is 10 times instead of 3 times. So let's go back here, turn my drawing feature back on, and the mean, E, is going to be n times p, so it's going to be 10 times 1/2, which will end up being 5. And again, I'll do the variance off to the left just because I'm running into myself here. So it's going to be n times p times q. So it's going to be 10 times 0.5. And q is again 1 minus 0.5. So it's 0.5 again. Whoops. That should be a 10. Just bad drawing there. So q is also 0.5. So that is going to give me, I think, 2.5. Let me put it in the calculator to be sure. Yeah. And then lastly, to get our standard deviation for part G, we'll just take the square root of 2.5. And I end up getting 1.581. That's if I'm rounding to 3 decimal places. So hopefully that helps you with number 23.